Okay, we are live, guys. Over to you, Sumit. The stage is all yours.
Thank you. Thanks, Hardik. I'm not able to share my video. Is it possible? Could you check from your end? Hello? I hope I'm audible, guys, right? Okay, great. First things first, it's always good to check these things at first. Okay, great. So, thanks, Hardik. Thanks for the short description. And hello, guys. Hi, everyone. This is Sumit Patel. As Hardik mentioned, I've been working with PayPal for the last 5 months. I've just joined recently. And this particular session would cover normal distribution, as it's a very basic statistical tool that you can use. So for what we'll go through is, let me just share my screen and we can take it from there. Just give me a minute. Hardik, it seems like I don't have all the accesses. I cannot share my screen even. Could you please check?
Wait a minute.
Yes, Mono, it would be the second half would be a hands-on session.
Yeah, now
Wherein,
you can share, I guess.
yeah, thanks, Hardik. Thanks. Let me just check. Okay. Right. I hope you guys can see my screen. If the screen is visible, then we are good to go. Okay, great. Thanks. Thank you, Shurinder. Right. So what we'll be discussing is on normal distribution, what it is, what are the numbers, what do they tell you, how do you interpret those numbers, and then in the end, in the second part of the webinar, what we'll do is we'll pick up Nifty 50, which is an index. It's an Indian index. So for my friends who are outside, who are from different countries, you have your own indexes. So for example, for this hands-on practice, we'll be taking Nifty 50 index and for the last 21 years to be precise. And then we'll see how we can apply normal distribution. We'll see whether the returns or whether the movement is or can be normally defined or not. So that's the second part. But first is we'll go through, it would be a very basic session. We'll start with what is a distribution, and this is what we'll be covering. What is a distribution? What is a normal distribution? What do you mean by a central limit theorem? What is the standard normal distribution? And what is the probability that is connected with a normal distribution? And then in the end, we have the demonstration. Right. So a brief about me. My name is Sumit Patel, as you guys know. I've been currently working as a data scientist at PayPal. It's been about 5 months. In total, I do have a work experience of 6 years in the BI domain, which is the business intelligence, data analytics, business analytics, dashboarding, data engineering, visualization, all those topics. My background is that I'm a civil engineer. I completed my engineering in 2014. Post that, I did my MBA from Symbiosis from 2015 to 17. And AXA was the first company that I was associated with. I worked there for about five and a half hours, 5.5 years. And post that, I moved to PayPal. So what I also do is I'm little active on LinkedIn, wherein I try to go on what the trend is, or what are the new developments on the AI machine learning fields. And I'm also a grad mentor, wherein I teach students during the weekends on data analytics, business analytics, data science, Python. Okay, if anyone wants to start, what is the process, what's the road, what are the tools they should be learning, and how do they apply those in the real life scenarios. My hobbies include stock market, sketching, taekwondo, and I do love to play cricket as well. And stock market, yeah, it's just the basic understanding numbers, understanding what are the various tools, financial tools, and how can they be leveraged. So that's pretty much it. And if you guys have any questions, any doubts, any issues, do feel free to put it in the chat section. Or I'll stop every 15-20 minutes approximately. And then I'll go back and check these questions. If you guys want, you can also unmute and talk. Okay, you can put up if your question is too long, then of course feel free to unmute yourselves and put forward your doubts, your queries. Okay. I'm just going through your chats. My audio is clear, right? Is it clear for most of you, majority of you, or you guys are facing some issues? Okay, great.
Yes, clear, Sumit.
So if somebody is, if you have any issues in understanding or if the voice is not clear, then most probably the issue is on your network connection. Right? If majority of you are not able to hear it, it's not clear, then the issue might be on my end. Okay. So my LinkedIn profile, sure, I'll share it when the session ends. Join from mobile, full screen. Okay, sure. I'll go full screen on the slides. How has my MBA degree helped me as a data scientist? Okay, so let me put it this way. I was interested in getting into the data field, right? I loved numbers. So one of the reasons was I was good in mathematics and physics, statistics during my school days. So that obviously that leads to engineering, as 90-95% of us do here. And the next best step for me was MBA, wherein I wanted to learn more about you don't get technically forward doing an MBA degree. It's about managing people, establishing connections. How do you work with different people? How do you get things done? So that's what that's what my MBA degree taught me. And then now applying it as a data scientist is obviously you have a lot of various different teams who work in the data domain. Like one person will not, one person will not be a data engineer. He'll not pull out the data from the databases. He'll not model it. He'll not do the visualization. So there are huge teams. And if you're working 8 hours, 5 hours, 6 hours, anytime in a day, obviously majority of it you'll spend in working with different people in different teams and keeping in mind what is the end goal, right? So it's very easy to keep working on a niche field and then forget what the end goal is and what you are actually trying to do. So I would say it's very difficult to put it, exactly on how, or this is what my MBA degree helped me to do this in my data scientist job. So that's a very difficult thing to do. But yeah, obviously any kind of degree, any kind of courses, anything that you learn, you apply it knowingly or unknowingly, you do apply it somewhere in your life. But to become a data scientist, whether or not you need an MBA degree, no, you don't need that. So you can even become a data scientist, or you can even be interested. You can learn coding without a degree, without a formal education if you're interested. So there are a lot of ifs and buts. Right. So basically, no go for a tech person. No go for a tech person. It is a go. Data scientist and machine learning is a field where tech people do, prevail, I would say. It's because once you strategize something, you always need to you need to do it, right? And you do it obviously by coding, by creating different software, creating different models. But if it is still a paper or if it's still a rough paperback in the back of your head and you're not able to apply it, then yeah, that's a little bit difficult, right? So, and how is it Okay, so we do have a chat section and we do have a Q&A session, Q&A section. So if any questions, obviously you put it in the Q&A session, and in the chats, that's fine. You can talk to each other. Yes, this session will be available on YouTube, maybe in a few days, I think, what, 3 to 4 working days, most probably. Right, so let's deep dive. It's done. Table of contents. So what is a distribution? What is a normal distribution? Central limit theorem, standard normal distribution, and probability. Most of you might have heard of these terms. And if you have not heard it, don't worry. We'll go through these in detail. And if you have already heard about it, then do pitch in your thoughts, right? If you think something can be added, subtracted, just feel free to put it there. Right. So what is a distribution? A distribution is it's done in a single column. Okay, you need a linear data wherein you try to see how many values, it's the count, how many values lie in those categories. So you have two types of data. One is your categorical data and your numerical data. Now for a categorical data, if you have 100 rows and you have a categorical column, like for example, can you guys give me an example of categorical column? Put it in the chat section. If you have any questions, put it in Q&A session. Q&A section. So yeah, gender is a categorical column. Yes, country is a categorical column. Name, it's not a category. It's because you don't know how many categories would be there in a name, right? There would be 10 people would have 10 different names. You can have out of 10 people, you can have 8 people with the same names as well. So name, it's still a gray area. Income bucket, yeah. Income would be a numerical variable. Income bucket would be a categorical variable. So a distribution is basically if I have 100 people and the column is gender, right? So I want to know how many people lie in different gender buckets. So that is a distribution for a categorical variable. Now, when it comes to numerical variable, let's say your income, height, weight, all these are examples of numerical column. Now, you need to create buckets, right? If somebody, let's take an example here. So these are the ages of 25 teachers of a school. Now, some of them might be 21.5, 25.6, 30.2, 40.9, and so on. So if you create a bucket for each individual numbers, or if you create the distribution for each individual age, it might not be possible. You'll have, if there are 25 teachers, you might have 25 different columns. So instead of that, what we do is we create a bucket. A bucket size is the length of the bucket. In this case, it's 5. So 20 to 25 years, 25 to 30 years, 30 to 35, or 35 to 40, 40 to 45, and so on. Now, how many, and these bars are a count of how many of those teachers are between 20 to 25 years of age. So 4. Now, how many teachers are between 25 to 30 years of age? 5. So this is a distribution. So can you tell me what is the relation between the bucket size and the number of buckets? So in this case, the bucket size is 5 and the number of buckets are 1, 2, 3, 4, 5, 6. Yeah. So what's the relationship between a bucket size and the number of buckets? Now, in this case, if the bucket size was 10 instead of 5, how many buckets we would have? Yes. So as the size of your buckets goes down, the number of buckets that you have increases. Yes, they are inversely proportional, right, Ravi? Now this is how your distribution looks like. Now, and you can, if I give you a column, so I hope all of you guys can create, or all of you can create a distribution chart, right? Now, right or wrong, you guys can do that. If I give you a random column, can you guys create a distribution chart out of it? Right. Doesn't matter if it is a categorical column or a numerical column. Great. So now these are the number of teachers. It's always the count. Okay, remember the length of the bar is the count. It's not average, not mean, not sum. It's the number of teachers, right? So the zigzag that you see here, it means that it does not start with a zero. These broken lines, it means it doesn't start with a zero. So if it is not to scale, so you see 20 to 25, the distance between 20, 25, 25, 30, it's uniform, but the distance between 0 and 20, it's not uniform. So this, if you have the zigzag before on the x-axis, what this means is that your data, it does not start from 0. Okay, you might have the minimum age of the teacher might be what, 25, 26. In this case, it could be 20 as well. So there is nobody less than 20 years of age. And similarly, there's nobody who is more than 50 years of age. Correct? Now, what is a normal distribution? Now, once you plot the distribution chart, once you create the distribution chart, and you see it is of this shape. Okay, it's a bell-shaped histogram. So this is what a histogram is. So the distribution that you create is actually a histogram. Right? If you ever see somewhere a Gaussian distribution or histogram, it's more or less it's the same thing. So when you create a distribution chart and it looks like this, it looks like a bell-shaped curve, then it is a normal distribution. Or somewhat, depending upon how close it is to a bell-shaped curve. If it is exactly like a bell-shaped curve, then it is very close to be a normal distribution. Obviously, you won't find an exact data set with 100% ratio, because there's always some similarities. So, or there is always some gaps. But if you draw a distribution chart and it looks like a bell-shaped curve, then you can be sure that it's a normal distribution. Now, it doesn't matter if it is, if you see a left skewed chart or a right skewed chart, it can be converted into a normal distribution. You can apply some log function, sine function, tan function. It depends. You can convert a skewed distribution to a normal distribution and then apply. So what's the benefit of creating something, or what's the benefit of adding, or if it is a normal distribution, then what kind of, or what plus point does it give to you? Right? Now, these are the properties of a normal distribution. If it's a standard normal distribution, or even if it's a normal distribution, this is the mean, the average, and this is the sigma is the standard deviation. So if you see 68.2% of the data lies within the first standard deviation. Now, if the mean is 0 and the standard deviation is 1, it becomes a standard normal distribution. So the only the only difference between a normal distribution and a standard normal distribution is, let's say I have a data set, I calculate the mean, which comes out to, let's say, 10, and the deviation, the standard deviation comes out to be 2. Now in this case, the mean is 10 and the standard deviation is 2. If I have to convert this to a standard normal distribution, what I'll do is I'll change each number. So for a standard normal distribution, the mean is 0 and the deviation, the standard deviation is 1. And for a normal distribution, the mean could be anything, the standard deviation could be anything. Now we'll see when we do the hands-on, we'll see how to convert a normal distribution to a standard normal distribution. Now, once you convert it, These are the properties of a standard or of a normal distribution. 68.2% or close to 68.2% of the data lies within the first standard deviation. Similarly, about 93% of the data lies within the second standard deviation. So -2 to +2, anything that lies in the yellow and green region, the probability of it, you can say, or the probability of something lying between the second standard deviation in a normal distribution is about 93%. What is it? 34, 47.7 to 94, 95.4. And about 99.7% of the data lies between the third standard deviation. So what does this mean? It means that if I randomly pick any number from the whole set, there is a 68.2% chance that it is within the first standard deviation. There's a 95.4% chance that it is within the second standard deviation. And there's a 99.7% chance that it is within the third standard deviation. Then it could go on, right? This is what it means. If I randomly, so if I have about 10,000 data points with me and it follows a normal distribution. So if I pick up any number at random from this data set of, or this data of 10,000 data points, there is a 68.2% chance that it will lie within the first standard deviation, 68.2% that it will lie in the green region, 95.4% chance that it will lie in the yellow or green region. There's a 99.7% chance that it lies in the red, yellow, or green region. Now, is this clear? Right. Standard deviation, it's a measure of how varied the data is from your mean. Now, if you have two data sets, they have the same mean. The average is the same within these two data points, within these two data. And if one has a higher standard deviation and the second one has a lower standard deviation, that means that the one with the higher standard deviation, the numbers are wider from the average. The one with the lower standard deviation or variance is, if the variance is low, that means, so variance is nothing but it's the square of the standard deviation. Okay, so sigma square is variance. Both of them measure the same thing. Both of them measure how far is your data from the mean. Got it. Right. So you cannot, let's say histogram is when you have the data set and you create the distribution using a histogram. This is how your histogram should look like for a normal distribution. And then this is the property. Now, if you have thousands and lakhs and crores of data points, if you create a normal distribution, or if you create a histogram of that, if you create the distribution, it will be or the higher your data, the closer it will look like a bell-shaped curve. In this case, in this histogram, you see it's not even. It's not going like this. It has some ups and downs, right? And it's not uniform. One of the reason is that the number of data points are low. It could be 100, 150, 200. Now, as your data keeps increasing, 10,000, 20,000, 30,000, lakhs, crores. So if it is a naturally occurring phenomena, or by nature, it should follow a bell-shaped curve. Like, for example, if I ask you that out of all the babies born around the world, now out of all the babies born around the world, if I create a distribution chart of the weight of a baby when it is born, right? Will it follow a normal distribution or not? Yes. Now, if I create a distribution of the height of all the 25-year-olds, so everybody who's 25 years of age, I measure their height one by one and I create a distribution of their heights. Will it follow a normal distribution or not? Right. So if you measure it could be the weight, marks. Okay, so some of you say no. Could you tell me why? Why will it not follow a normal distribution? Just think about it and put it in the chat section, no problem. It may be the same. So think about it. You pick up 10,000 people who are 25 years of age and you measure their height and you plot a distribution of their heights. Could be highly skewed, but if your data side is huge, if you have 1 lakh or maybe 10 lakhs of data points, it will follow a normal distribution. And the higher your data points, the closer it will look like a bell-shaped curve. Yes, there are some outliers, but how many? We are looking at the percentage, right? So out of 100 data points, or let's say out of 1,000 data points, we'll have 3 who are outliers. Right, out of 10,000, out of 1,000, we have 3 who will be outliers. And out of those 1,000, we'll have 682 who will lie within a first standard deviation of the mean. Yes, there would be. No doubt there will be outliers. Somebody could be very tall, somebody could be very short to be for a 25 years old, but how many? Now remember, we are interested in the number. How many outliers? 1, 2, 3, 4. So if the data follows a normal distribution, that means that, and if you call an outlier as something which is beyond 3 deviations, 3 standard deviations from the mean is an outlier, then out of 1,000, under ideal scenario, you'll have 3 outliers. That's what the data says. And this is a researched data. Okay, so I don't exactly remember who came up with normal distribution, but there was a lot of samples that was taken and this measurements and calculation was done, and these numbers came up after the research. And then it is used, just like your theorems, right? You might have studied some theorems in schools and you might have got some questions saying that prove the theorem. So somebody was there who proved the theorem and now you're using the theorem, right? There would be somebody who created the a plus b whole square, and going forward you just use the formula. You don't go ahead and prove it. So this is what it is. So research was done and these numbers were finalized, and then what we are doing is we just see whether something follows a normal distribution or not. If it does, yes, Gauss. It is also called Gaussian distribution. Thank you, thanks for that. So this is a Gaussian distribution, right? Now right, so we just use these numbers. Now if we know that a data follows a normal distribution, we just go ahead and try to find out the probability. What is the probability of something lying between this and this? What is the probability that a number will lie between this and this? Standard normal distribution is a probability distribution. Normal distribution, yeah, both of them are same. Normal distribution is, it can go beyond 1, right? It can go beyond 0 and 1. So it won't be the probability. Standard normal distribution is a probability, right? Any questions here? Any issues in understanding what a normal distribution is and what is the property of a normal distribution? And so can you guys give me some examples of what kind of data will follow a normal distribution? So speed of cars running on a road, yeah, could be. Now, if I plot the score of an opening batsman for the last 20 years for any team, will it follow a normal distribution? Think about it. So for the last 20 years, if I plot the score of every opening batsman in cricket history of last 20 years, if I plot the score of every batsman, every opening batsman, will it follow a normal distribution? Right. Similarly, if I plot the distribution of every batsman that came in at number 5 to bat, will it follow a normal distribution? Why? What's the difference between an opening batsman and a number 5 batsman? It's the same thing, right? So in the last 20 years, if I pick up the score by every number 5 batsman in the history of cricket in the last 20 years, the score of every batsman playing at number 5, will it follow a normal distribution or not? Yes. So one represents the population, the other is sample. No, it's you could say, because my assumption here is that in majority or more than 95% of the matches, both the number 1 and the number 5 batsmen come into bat. So you're sure that the opener or the number of batsmen, the opening batsman will come to bat, right? But you're not sure whether number 5 batsman will come to bat or not. So both of them are population. So if I've taken last 20 years, so it's more or less similar. Got it. Now keep thinking about such examples. Now look around you, think of, let's say, the amount or the volume of water that comes or different households use in your area. Right? Let's say in an area of 100 hectares. So the volume of water that comes to each house, or the volume consumed, or volume of water consumed by each household, will that follow a normal distribution or not? So keep coming up with these questions and try to answer them. If your answer is yes, so why is it yes? If it is no, so why it is no? Not here, but do this exercise with people around you. Okay, great. Let's move on. Now, what a central limit theorem states is that if you have a population and you pick up random samples of size more than 30, if from the distribution or from the population that you have, if you keep picking up random samples of more than 30 and you plot or you see the distribution of the mean of these samples, like for example, if you have a population of 10,000, okay, out of those 10,000, if you pick up 30 samples 100 times, okay, you could do it with repetition, without repetition. With repetition would be better. Okay, so the 30 samples that you pick, calculate their average, put them back. Pick up another 30 samples at random, calculate their average, put it back. Pick up another random 30 samples, calculate the average, put it back. So if you do this 100 times, 200 times, doesn't matter how many times you do it, you would see that these average, the means that you calculated, always follows a normal distribution, irrespective of what your original samples distribution was. So if it is a left skewed, right skewed population, if you pick up random 30 samples, keep adding or keep calculating the mean, and if you create the distribution of the means of the averages, it always follows a normal distribution. That is what is meant by a central limit theorem. Irrespective of the distribution of the population, the distribution of the means of samples greater than 30, or if the sample size is huge, then it could be 20, 25 as well, right? Always follows a normal distribution. So that is what, in short, your central limit theorem says. Now, your task is, you have understood the theorem, right? You have understood this. Now go ahead and see where it is applied. How is it used in real life scenarios? Because it doesn't make sense if you just know things and don't apply it somewhere, right? If we all know what central limit theorem is and nobody applies it, then it's of no use. So this is your task. Go back and check and see what or where is it used. Obviously, these all of them are used in statistics, but where? During surveys, during the initial feasibility study of something. That's where these probability or statistics come into the picture. Right. So going ahead. Great. Time for hands-on. I'm changing my screens. Let me share the data with you guys. Right. Can you guys see my screen? See the Excel sheet with yellow and blue numbers, blue backgrounds. Yes, Sanjay, this recording will be published in the Analytics Vidya YouTube channel. I think after 3 to 4 days, should be at max 1 week. Fingers crossed. Okay, so where do you get this data from? If you just Google Nifty 50 last or Nifty 50 historical data, you'll get the link of Nifty indexes. It's by BSE, which is your Bombay Stock Exchange, and you'll get this data. Now, I won't go into the details of what options are, stock market, will not go there. But for now, remember, indexes are a combination of various stocks, various companies. And the index is a measurement of if all the companies do well, or it's a weightage. Let's say if an index has 10 companies, like Nifty 50 has 50 Indian companies with the 50 companies with the largest market cap in India form the Nifty 50. And Nifty 50 is an index. So it has its own price. And that price depends on the weighted average of the stock price of these companies. So a weighted average of what? A weighted average giving higher weightage to companies with higher market share. So bigger companies have bigger share, smaller companies have smaller shares. Think of it this way. Now, Nifty 50 has the top 50 Indian companies with the biggest market share. Reliance, Infosys, TCS, HDFC Bank, all of these. And when these move, then the index moves, depending upon the weight, obviously. If Reliance has the highest weight and it moves less, but it will have high impact on the Nifty. If, let's say, the 50th index, the 50th company, I don't know which one is it, if it moves a lot, it might not have the same impact on the Nifty 50 because its weightage is low. So if you go to the BSE site, the Bombay Stock Exchange, you'll find this data. You can download it on a yearly basis. Like when I downloaded, I did this exercise about a year back, and I was not able to download more than 365 days of data. So I don't know if it is still the same or not, but if you're not able to do it all at once, so you'll have to do it year by year. Now this is what you'll have: the date, the opening price on that day. So in India, the market starts at 9:15 a.m. So these are the price at 9:15 when it started. High is on that particular low on that particular day. What was the highest point touched by the index? Low is what was the lowest point that was touched by the index, and close is at 3:30. What was the price of the index during the closing? So this is for every day. Okay. Since the last 21 years, I have the data till 30th December 2022. So for this 2022, I downloaded it a few days back. For the rest, I did it about a year back. So just to see what's going on. So any doubts here in understanding the data, understanding the yellow part? The date, what was the opening price, what was the high, what was the low, and what was the closing? It is for the index, it is for Nifty 50. It is, you could say, a combination of the top 50 companies of India. Okay, right, somebody was saying to zoom in a bit. Yeah, is this good? I think you should. Let me know if you want to zoom it further, because some of you, I understand you are I'll share this data set once we are done with the session. I'll share it with the analytics with your team, and you can get it from there, or you can contact me on LinkedIn and I'll share with you there. Okay, right. So no doubts in the data as it is. These are the ones that I have calculated. Here you have a formula directly. You can put in year, and it will give you what is the year of the date. It will extract it from there. Then similarly for month and for day, which day it was. So market is open from Monday to Friday, and these are the two moves that were calculated. The overnight move is what percentage was the move in the opening price of the next day and the closing price of today. Intraday move is within one day, what was the difference in the opening and the closing price. Now, can anyone tell me why did I choose to go with the percentages and why not the numbers? Why did I convert it to a percentage move rather than seeing the absolute move of the numbers? So this is what 5 to about 50, 55 points of increase. Anyone? Just think about it. Easy to convey the message. Yeah, they show the extent. Yes, keep it between 0 and 100. Yeah, could be. Yeah, but these are yes, they are valid reasons, but they are not the major reason. Price different range may yeah, price is different to get a probability score. No, the major reason was that I'm taking the data of last 21 years, right? So a move of 50 points in 2010 is not the same as the move of 50 points in 2022. So if in 2010 Nifty moved by 50 points, it was a huge thing because the price was 500, right? 5,000. So the move was 1%. But now Nifty is at 18,000. So a move of 50 does not have the same weightage. So if I did take the absolute numbers, I would not be doing justice to the numbers, because 50 points back in 2010 does not have the same weight as 50 points today. right? Is this clear? Why taking the percentages and not the absolute numbers? Yes. Right, Mokshita. Great. Now this is the intraday move and this is the overnight move. You can have your own moves depending upon what kind of analysis that you want to do. Now let's go ahead. What do we need for a normal distribution? In order to calculate a normal distribution, or in order to plot the histogram to see whether it is a normal distribution or not, what do we need? Yeah, we need the histogram in the data points. Okay, so we do have the data points, and all we do is we need a histogram. So I'm taking it for the intraday move. Let's insert. You'll find the histogram here. Let me put it on top. Let us clean it a little bit. Format the axis. So anything below 4 and anything above 4, let's put them into one category. Just to beautify my histogram a little bit. Okay. Overflow bin and an automatic overflow bin and an underflow bin. Overflow bin of 0.04, 4%, and an underflow bin of minus 0.04. Right. So this is how my data looks like. This is how the histogram looks like. Now, what do you think? Is this a normal distribution? Right, it looks like a normal distribution, right? Or very, very close. If I change the width a little bit, you'll see an exact normal distribution. Great. Now, what do I need next? I know that this is a normal distribution, and the intraday prices of, or the intraday move, the percentage move follows a normal distribution. I have established that. Now, what more, or what else do I need? Yes, mean and variance. So let me put it on this side. I'm working with huge tabs. I've zoomed in my Excel. Okay, so standard deviation. It's also called as TD. Okay, mean, direct average numbers. STD is the standard deviation. P is for population, S is for sample. But if your population size, if the numbers are big, then doesn't matter. Both of them will give you very close numbers. Right, so this is what I have. The mean is 0.07 minus 0.07. and the standard deviation is 0.92. Now what next? I know the mean, I know the standard deviation as well. What's the next thing? Now what does this tell me? It tells me that the mean movement of Nifty, the intraday movement of Nifty 50 is minus 0.07% over the last 21 years with a standard deviation of 0.92%. Does it make sense? So it is very close to 0%, right? So if the average move of Nifty 50 is 0% intraday movement, and the daily movement or the overnight movement is 0.11, and the overnight standard deviation or is 0.62. Now what does these four numbers tell you? When we have an extremely large sample size, everything follows a normal distribution. No, it depends on what you are trying to figure out. There has to be a common base, like the height of all 25 years old. If I said the height of everybody from 10 years to 50 years, well, there is a bias as well, right? Because I know that the height increases from 10 years to 20, 25. But this is an additional thing which is not constant. So it's partly correct that extremely large sample size, everything will follow a normal distribution, but it is not everything. Something you'll have to keep constant. So that means that, or the information that I can extract from this is, there is the probability, or there is a higher chance of Nifty moving within the night when you are sleeping, rather than moving during the day when you're trading. If you're trading, if you want to get into that, right? And the standard deviation is low. That means that the variance is not high, or the movement from the mean of 0.11 is not that big, which is opposite in the intraday movement. So intraday, first, the movement is negative, very close to negative, and the standard deviation is also higher. That means most probably the Nifty, where it is starting and ending, it moves a lot, but the starting and ending point are close to each other. But during the night, the mean is a bit higher and the standard deviation is also lower. So taking into account these numbers, you should be trading at night, but the market is closed. So when you wake up, when 9:15, the bell rings, everything goes here and there. But there are certain other cases. So if you see mean of 0%, close to 0%, does this mean that Nifty on an average should not have moved and it should have stayed at the price where it was 21 years back? So an average move of minus 0.07, doesn't it mean, or doesn't it look like with an average of minus 0. Or a mean of minus 0.07, Nifty should have stayed at those levels, if not go lower, what it was in 2010. Yeah, average, mean. These are not the actual numbers. Yeah. Now, one thing that we are not getting here is, this is just the intraday movement, or in a day where it moved. But as we see, there is an overnight movement as well. So intraday movement might have been lower, but the overnight movement is higher. So let's say if something started at 5,200 and moved till 5,230, next day it started at 5,300 and closed at 5,310. So the intraday movement or the overnight movement is higher. Now we are only checking the intraday movement. So the statement that I made is not correct, but instead, if I made the statement that when Nifty opens, the probability of it closing within 5%, or not even 5, where Nifty open, the probability of it closing within 0.5% is higher, is good, right? Or the probability that Nifty will close very close to where it opened, right? That's what this means. Now remember, the data that you're working with, you need to make sense as well, because it's not all numbers. If you just blindly trust the numbers, things will go bad very fast, right? So this is the intraday movement, and this is the standard. Okay, now what do we need next? What do you want? Can I calculate the probability using these numbers? Got it. Now, but we had, if it is within first standard deviation, it is 68.2%. If it is within second standard deviation, 95.4. Within 3, 99.7. Now, what if the standard deviation is 1.135? What is the probability then? We don't know, right? So for that, we have a table which is called your z-score table. So if you go online, you Google the z-score table, you'll get it. But the z-score table, so what it does, it gives you the probability of the standard deviation. So if your number, now let's say if I want to calculate Nifty 50's movement in the next one day. So the mean of minus 0.07 and the standard deviation of 0.92. It is not, this is the normal distribution, it's not the standard normal deviation. So the next thing is I have to convert it to a standard form. So instead, what I do is I change all of these numbers by the number minus the mean divided by the standard deviation. Now this is the step to normalize the data. Oops. What happened? These are all percentages, so I have to convert them standard deviation. You see, mean of 0, mean of 0 and standard deviation of 1. This has been standardized. So instead of 0.6, it is actually 0.73, the standard, or normalizing this number. So 0.01 is actually 0.1. So I'm converting everything into a standard normal form. So a standard normal is what? Mean is mean of 0. So if I subtract every number by the mean will be 0, right? And the standard, if I divide everything by the standard deviation, the standard deviation would be 1. How is this helpful for me? Now let's say today, what if, let's say this is the closing of today. Now I want to take a position of 18,200. Now take a position, that means depending upon what the probability, or depending upon whether or not I make profit at 18,200. If so, there are various options. I have the choice of, if Nifty reaches 200, I can make profit then. If Nifty doesn't reach 200, I can make the profit then. Let's say I just want to calculate the probability of Nifty reaching 18,200 in the next trading session on Monday. So what's the percentage increase? Equal to this. So what's the percentage increase that I'm looking for? It's 0.52% increase. Now, what is this 0.52 in terms of my standard? So again, I convert it into, or I normalize this minus the mean divided by the standard deviation. Again, it's a number, right, which is 0.65 of the standard deviation. So this is 0. What is this? 0.65 means it is 65th percent of a standard deviation. So standard deviation is 1. So this is within 1, right? So anything between -1 to 1 has a probability of 68.2%. So Nifty reaching 18,200 intraday on Monday is something. It's not exactly 68.4, because the probability of 1, or the probability that the number is within the first standard deviation, like the number lies between -1 and 1, is 68. But what is for 60? 0.65. This is where your z-score comes in. Okay, just a minute. So I'll move the pointer. Overnight is open price of today minus the close price of yesterday divided by the closing price of yesterday. So that's the percentage increase during the night. The intraday move is your closing price minus the opening price of that particular day divided by the opening price. Now this that we have is the Z value. Let me see if I had the Z table. I did. So A Z table is nothing but it gives you the corresponding probability. It gives you a corresponding probability of your number, or of that data hitting that number or not. So in this case, what this table will give us is what is the probability of Nifty reaching 18,200. So, or let me just download a new one. I'll share my full desktop with you guys. Right, it's better. Now, till here, if you've not understood anything, if something is not clear, just feel free to put it in the chat section. Okay. The screen is visible, right? Okay. Right. So this is the table. Now, what was our number? Our number was 0.65, right? And since the bell curve or the standard normal curve is it's symmetrical, so whatever you have on the right side is the same that you'll have on the left hand side, correct? Now, a z-score of, well, let's first find out where our number is. 0.65. So how do you do that? You go to 0, 0.0, 0.1, 2, 3, 4, 5, 6, and then this is 0, 1, 2, 3, 4, 5. So what do you have? Minus what? 0.2578. Confirm. 0.65. Yes. And this is for minus 0.65. Remember. So 0.2546. 0.254. Now what is this? What is this number? Now this number tells you that if it was minus 0.65, minus 0.65. Now what will be it? It would be this minus the same number, but going back below. So the probability of it or the probability of Nifty going below 18,010 is 25.46%. Next day. This is what this number of minus 0.65 tells you. So this is somewhere here. Minus 0.65 is somewhere here. Okay, so 25% chance that Nifty is below. So In this case, if it is -1, so your z-score would be 13, 15.7, 15.8, 0.0158. Now let's confirm this. Of -1, -2. 0.0 is 0.0228. So a 2% probability, 2.28% probability that your number is, so 2.2. You see, it is in the red zone or below. Now, what is for -1? For -1, it is 0.1587. So 15.87% chance that the number is less than, or it falls in this red and yellow area. So 15.87 is what? 13, 14, 15, 16. So 13.78. That's the same, right? Now, coming back to this. So the probability of something, or the probability of Nifty going below this number, the probability of Nifty going below -0.65, or the probability of Nifty going below 18,016 is 25.46%. So can we calculate the probability of Nifty going above 0.65? Now that is again 2546, right? So because it is symmetrical, again, remember. So the probability of something lying below first deviation or above first deviation is the same. So the probability of something going below is the same as something going above. So the probability of Nifty going below 18,010 is the same as Nifty going above 18,200, which is 25.46%. But we don't want that. We want the probability of Nifty staying below 18,200, for example. Now, if I want to know the probability of Nifty being below 18,200 is what? 1 minus probability of Nifty going above 18,200, which is 74.5%. Is this clear? It's a game of probability now. And also a very important thing here, it's a big, huge assumption that we are taking. We are only looking at the numbers. We are only looking at Nifty from the numbers perspective. Okay, we are not doing anything. We are not understanding the market. We are not doing anything. We are just looking at Nifty numbers in the last 21 years. And this is what we are depicting from there. Now, obviously, on Monday, these are not the exact probabilities. But if you span it a little bit more, let's say instead of one day, if you have a month, 3 months, 4 months, then this is most probably likely to stick, because statistics is all a game of numbers. If you have a smaller sample size, then your numbers will deviate a lot. Your chance of error will be very high. But if your sample size keeps increasing, the chances of error go down. Okay. Now again, let's say this is what we have. Now this is the intraday movement. You can also calculate the weekly movement. Now if somebody is interested in options trading, Indian options, first is you'll have to study what are derivatives, what are options. Now Indian options expire on Thursdays, right? On every Thursday. So instead of this, if you calculate the movement of Nifty on every Thursday, you can have a rough idea of how Nifty moves within a week. So let's pick up some other numbers. Let's take one last hands-on and then we'll be open to other questions. Let's say 18,250. If I want to calculate the probability of Nifty going above 18,250, right? Now first, obviously, I'll have to convert it into a percentage, or I'll have to convert it into standardized value first. This minus this divided by, and then again this. This is the percentage increase that I'm looking for. And then I'm standardizing it to get the z-score. Right? So it is 0.95. Now, what is the probability that it is above 0.95? So let's go back to, this is not the correct table. Yes, this is the correct one. Okay, so what was our number? 0.95, right? 0.9, 1, 2, 3, 4, 5. 0.95.8289. Now remember what this tells us is anything below this. So anything below 0.95 is 0.8289. Score. And this is the p value, which is the probability value. Which is 0.895, 0.8289. So what is this? It's the probability of Nifty staying below 250. So the probability of Nifty moving above is 1 minus this. Or there's a 17% chance that Nifty goes above 18250 on Monday. Again, disclaimer, these are just numbers. And since one day is a very short period, the chances of error are really high. If you want to standardize it a bit, so instead of taking or looking at the daily numbers, look at the weekly numbers or monthly numbers even. So what was the monthly starting, monthly end? Now in those cases, the chances of error might be low, right? Now you know that the probability of Nifty moving to certain numbers is this. Then if you want, you can explore more to understand what kind of positions do you want to take. Now that's a completely separate thing. That's on options trading. That's a different topic, different risks, different measures. But this is from a normal distribution point of view. This is what we can do. Now, of course, if the data size is small, if the sample is small, the error will be higher. In any statistical example, it's the same case. Wherever the sample size is not big enough, error is very high. If the sample size is big enough, then the chances of error are there, but they are low. Got it? Any questions, any doubts still? Changing normal distribution to a standard distribution is we should do to find the z. Yeah, this is the z-score. So this was, now we saw that it follows a normal distribution. Now we converted it into a standard normal distribution, and these are nothing but all of these are z-scores. And using these z-scores and this chart, you can find out the probability. Now again, this is only for standard normal distribution. Make sure you don't use these numbers for normal distribution. You'll have to first standardize it, convert it into a z-value, or else these numbers will not make sense for you. Okay, and these numbers are not anything else but the probability, straight hell probability. So the probability of something moving, the probability of something going beyond this or below this is this much. And then once you get the probability, you can go ahead and do what you want. Right. So that's pretty much it. Thank you guys. This I'll put my now it's open. We are open for a question and answer session. I'll put my LinkedIn link. If you guys want to connect, you can ping me there. I am active. I would say I'm not overactive on LinkedIn. I am a little active, so most probably I'll get back to you within a day or so. Okay. Now, any doubts, any questions, any issues till here? I do have two questions. How to measure the sample size? The sample size is the number of data that you have. Now, from like a good way to think, or I understand that sample size is the number of data that you have, but your question is mostly how to reduce the errors while calculating, right? Now, if the sample has lower standard deviation, right, then it's good, and then your probability would hold nicely. Like for example, in these cases, if you check the same data, there are certain days where Nifty fell by more than 10% as well, right? 7%, 14% during Corona, during the 2008 crisis. And there are certain days where there was a movement of more than 4% upwards as well. But these were all daily movements. If you change this daily movement to a weekly movement, then your chances of error will go down. The standard deviation goes down a bit. If you change this to weekly movement, to monthly movement, then your error goes down further. The data that you have, let's say, what's the probability that Nifty is highly volatile within 1 hour, or Nifty is highly volatile within 1 month? Where will you find more volatility? More volatility is the more standard deviation, a higher variance. Right? So, what sort of problems do you face at PayPal? Currently, now I have not faced any problems yet. So, since I've mentioned that I'm just starting, it's about 4 to 5 months that I've joined. And as such, even the people I know working, mostly when you define problem, there could be various buckets, but in each bucket, from HR point of view, from working point of view, from management point of view, everything has been pretty good. It's pretty awesome till now. Are those shapes for skewness? Which ones, George? Is it the final slide wherein business problems? Very different. Each team has a lot of different other problems. For us, I work with I work with the strategy team of seller risk teams for a Zettel. And what we do is we mostly go through the data, create strategies, apply them. So yeah, each business has its own problems. From a PayPal's perspective, I won't be able to tell you much, right? Okay, shapes for skewness, George. I did not get that. Maybe you could. Maybe refine it a bit and let me know. Okay. Anything else, guys? Any other questions? Anything else that you guys would like to ask? Just feel free. We have what, 5 more minutes, I could say. I see half of you have left, but that's fine. If any of you are interested in knowing more, understanding more, just feel free to reach out to me and we can connect. I'm going through your questions. Yep, welcome guys. So I did share my LinkedIn link with you guys in the chat section. It's there. I'll put it again. There you go. Right then, guys. The shared file, I'll share it with the analytics with their team, as well as if you ping me on LinkedIn, I'll share it with you there. Or if you want to go, because this is it's a very important step when you work as a data analyst or data scientist or any other analyst as such, is gathering the data. So if you want to do it from scratch, you can go to Google, just type Nifty 50 or whatever your index is that you want, historical data. And then you will be able to download this. Date, open price, high price, low price, closing price. That's all you need. So go ahead, gather the data. Maybe I've changed a few numbers in my data set, right? To show that, yes, you should trade and then I take your opposite positions. No, just download your own data, clean it up, because that will be a good practice as well. And then start to apply all the models and everything that you want to do there. Okay. I think we are coming to an end. No other questions. In next 1 minute, we'll close. But Hardik, I think you can take it from here.
Sir, Hardik disconnected, so I think you're the host now, so you have to end the session for everybody.
Sweet. Okay, guys, thank you. Have a good weekend and see you on Monday. What's the probability? Yeah. And yeah, enjoy. Bye-bye.